Hello everyone. In this lecture, we are going to learn about how to design skirt. Our flagship course is Master Static Equipment Design and PVElite and Master Welded Storage Tank as per API 650. We have curated courses to suit your learning needs, so do visit our learning platform on scootoid.thinkific.com.
Let us start with the first and most important element of your skirt design, and that is skirt shell. Okay. So before I tell anything, what do you think? How you will design skirt shell? What are the types of load which will be acting on this skirt shell? Failure in the skirt, basically the dead weight, which will be coming on the skirt. Okay. So dead weight will basically exert a compressive stress, right? Then there will be moment because of wind or seismic or any eccentric load will exert a moment. And because of moment, it can have stresses due to bending stress. Okay. Now, what will be the compressive stress? How we can calculate compressive stress? How we can calculate the compressive stress acting on the skirt? Any idea? F by A. So F is basically what? The load, which is the dead weight, okay, coming on the area, the cross-sectional area of the skirt, like we have drawn here. What will be the cross-sectional area of the skirt? You can, neglect T compared to radius. Okay, so you can ignore that. You can consider thickness is very small compared to radius, okay, which is typically the case. Okay. Great. So with that, definitely you can calculate the area of the skirt. Okay, pi d T. So instead of D, if you're writing R, then it will be 2 pi RT. Okay. Now we did with already we have. Okay. We have the area. We can calculate the stress coming on the skirt. Okay. Now this can be different for different conditions. Like if you are doing hydro in vertical condition. Okay. Let us see your vessel is small in size and you are able to do hydro in vertical condition, then your dead weight will be the hydrostatic test weight. Okay. In normal operation, whatever liquid is there with whatever height filled, that will be the dead weight. In empty case, that empty weight. Okay. That will be there. But that is only one part. Okay. That is the compressive stress created by dead weight. As we discussed, there will be additional stress due to bending. And you all know that if I have a bending, one side, there will be tension and other side, compression, right? Tension one side, compression one side. And due to dead weight, you remember, we had compression. Okay. So now, if you consider that, if you consider this portion, okay, wind is flowing like this in this direction. Okay. So there is a moment like whatever we have indicated. So this side, there will be tension and this side, there will be compression. Okay. So now if you combine with the dead weight, okay, here there is tension, but because of dead weight, there is a negative stress. Okay. So if I write W as a stress due to weight, so it will be T minus W. Okay. But this side, it's minus C minus W. Do you agree? Do you agree, guys? Yes. Yes, yes. So very simple, right? So this side, the weight is also acting in the downward direction, while because of the moment, there will be stresses coming again in the compressive. So here it will be addition. Okay, here it will be tension minus. So unless you make the load case, you cannot specifically say that which may govern. Okay, so it's always, you have to do the calculations to know about that compressive is governing or tension is governing. And in which case, like you may have hydrostatic, you may have to check for operating, you may have to check for empty case. Okay, because empty case, your minus this W will be smaller. That weight is less, quite less compared to uh, you know the hydrostatic test time. Okay. While in this case, if your weight is small, your moment may start governing. Okay, so tension may start governing. So unless you calculate, you cannot specifically say that which case will be governing. So you have to calculate to know about it. Okay, great. Now bending stress, how we calculate? M by Z. So what is the Z of the skirt? Pi r square T. Okay, you can remember that any cylindrical section, the section modulus is pi r square T. Okay, so just divide that with the moment which you have got, maybe because of wind or seismic or due to any piping load, whatever. If there is any moment, that moment you add, okay, and then divide that with section modulus. Okay, now it's time to combine. Okay, so stresses in the skirt will be this. Now both the different sides, you need to do the different additions and compression. So you have to find the tension stress also, you have to find the compression. If you'll see in the PVElite also, you'll get the both the columns are calculated. In tension, how much stress is there? In compression, how much stress is there? You have to always remember, okay, that your compressive stress may not be allowable compressive stress I'm talking about. So allowable compressive stress may be different than the tension, and it may be much lesser. Okay. So that is also one reason to calculate both of them separately and then do the comparison separately for tension and compression. So we have to follow that. Okay. Now, see here, I'll give you the, so this is what we'll do for stress calculation. If you want to calculate the thickness now, okay, which is not given in PVElite, so what you can do, just break that, that area, I can write it as, 2 pi RT. Z, we always know how to write in terms of T, pi r square T. So if you write it like that, T you can take this side, and then you will be able to write the same equation as this. So thickness of the skirt will become this. Okay. You can include the efficiency also of the skirt, because your skirt may be butt welded, okay, and radiographed. So that also you have to consider here. So joint efficiency will also be part of the thickness calculation. Okay. Now coming back to the original question, if this equation can be written like this, why we don't calculate the thickness of the skirt and why we do the combination instead? We just check the stresses rather than finding the thickness, okay, for the skirt. What is the reason? What might be the logic behind that? So the logic which I think, okay, as per my opinion, thickness may differ for various combinations, because there are lots of variable thicknesses, depending upon the multiple cases which you can create. And that is the reason code, instead of calculating the thickness, it calculates the stress. And for that case, what is the allowable? And it compares with that and qualifies. Okay. So basically it qualifies based on stress, because for each case, your W and M both are changing. Okay. So that is the reason it does not print the thickness calculation of. But if you have to do it, you can do it like this. You can consider one case which you might have governing, which might be a governing load case. You can just use that or if 2-3 cases are there, you can just put that values and compare also.
For in-depth training and to learn more about these courses, register with the link in the description.